Alright, finishing up where we left off. So with these last few, I want you guys to try them first, and then you can check your answers. So you do need to practice these though, because these are not going to come very naturally. It is a lot of trial and error. So make sure that you are actually practicing and not just sitting there for the next like 5 minutes doing nothing. So pause the video. When you get done, you come back and then you can check your answers, and I'll kind of walk you through these. So with this first one, again, we want to write all of our elements, and you want to write just the elements. Do not write the compounds by themselves, because see how silver and sulfur are together on this first one, and aluminum is by itself, and then in the product side, silver and sulfur are together, aluminum is by itself, aluminum and sulfur are together on the product side, silver is by itself. So this is what we call a single replacement, which you guys will learn about next time. So you want to split everything up. You want individual elements. Okay. Now it is easiest if you kind of keep them in line. So because I have silver first on the product or the reactant side, I want to do silver first on the product side. So it just kind of helps keep everything in line. Okay. On this side, we've got 2 silver, 1 sulfur, 1 aluminum. On the product side, we've got 1 silver, 3 sulfur, 2 aluminum. So best way to kind of go about this is start with sulfur, because it's the one that's in the compound on both the product and the reactant side. So we've got 3 sulfurs over here on the product side, so we're going to give a coefficient of 3 over on the reactant side. So now we have 3 sulfur, but again we have to distributive property. Okay, so 3 times 2 is now 6. Okay, so we have 6 silver. We're going to come back over to the product side. We're going to give it a coefficient of 6. So now those are balanced. And the last thing is we've got 2 aluminums. Got to give it a coefficient of 2. Everything's balanced. This is your final equation. For this next one, so we have sulfur, so this one's taking our word problem, and we're just going to, so it's kind of like math, taking a word problem, we're going to turn it into an actual equation. So we have sulfur plus oxygen gas or dioxide yields sulfur trioxide.
2 more minutes.
So again, we've got S, we've got O, we've got S, we've got O. Okay. Starting with oxygen here, we have 3 oxygens. Okay. So we're going to give this a 2. 2 times 3 is 6. Bring that over here. 3 times 2 is 6. Distributive property, 2 times 1 is going to be 2, so now we need to add a 2 over here. Everything's balanced. Okay. Now, the last thing with balancing our equations is if you have a polyatomic ion, such as nitrate, which is what it is in both here, keep those polyatomic ions together. It's going to make your life a lot easier. Okay. So these are the only things that you keep all of the elements together. Okay. Everything else you will split up. So we've got silver, we've got nitrate, we've got copper. So we'll do the same over here, silver, nitrate, whoops, and copper. Okay. Again, I want you to do these ones on your own. Check your answers, so use the video only to check your answers. Actually try it. So on our reactant side, we've got 1 silver, 1 nitrate, 1 copper. On the product side, we've got 1 silver, 2 nitrates, 1 copper. So because the only difference here is the 2 nitrates on the product side versus only 1 on the reactant side, I'm going to give it a coefficient of 2. Switch our silver, come back over here, give it a 2, and everything else is balanced. Okay. So we have one more example problem here, and then you guys will get your homework. Zinc, copper, nitrate,
Back in 30 seconds.
zinc, copper, nitrate, 1, 1, 2, 1, 1, 2. So actually this equation is already balanced as it is. Okay. Alright, so what I want you guys to do now is I want you to come up with a real world problem for balancing equations, similar to like what we did with bicycles. So, and then I want you to have a partner balance the equation. So I want you to come up with the skeleton equation. Okay. So again, an example of that would be a frame plus wheels plus pedal plus handlebar gives you a bicycle. Okay, so I want you to come up with something kind of like that. It can be anything you want, and see if you can have a partner solve it. Now for your homework for tonight, this is part 1. You're also going to get a worksheet. I don't know if you'll have time to do the worksheet today or if you'll do it next time in class. But I do want you to do these questions from the textbook. You can just put them into your notebook.
Alright.
Okay. And then finally, to finish up, I want you to, on a scale of 1 to 10, tell me how you feel about this concept of balancing equations. A 1 would be you have no idea what we just spent the last however much time talking about. 10 means you could probably teach it to somebody and feel very confident with this. Again, guys, if you have questions and you are seeking some help in Benson, Miss Sekle is down the hall in 233, I believe. She can help you. She has after-school tutoring on Tuesdays and Thursdays. You can ask almost any of the science teachers to help you out. And then there's so many videos out there, so don't use any excuses for not getting this done, because you're only going to get better at this if you practice it. So don't just ignore it and hope it's going to go away, because it's not. So if you have questions, ask Miss Sekle. You can email me, but no guarantees that I'm going to get back to you right away. So that concludes all of our information about balancing equations.